Okay, number 17, find the intervals of increase and decrease for the following function. Shown in the graph, all intervals should be accurate to 2 decimal points. So, looking at this, we're going to figure out where we have our slope is 0. So we know that's a minimum or a maximum. To do that, we're going to take the derivative and set it equal to 0. Okay. Okay, so this one you can't factor it easily, so you're going to have to use the quadratic equation, if you remember that. So then you're just going to plug all the values into the quadratic equation. I'm not going to give you one like this that requires you to use the quadratic equation. It would definitely factor easily if I gave this to you. So don't worry. You don't have to memorize that. Even though you probably already have it memorized, maybe. Alright. So it's wanting to know all the areas of increasing and decrease areas for the following function. So our critical points where the slope is 0 is 2.27 and 3.06. So we can see on the graph it's increasing. We'll say that point is approximately 0.27 and that point, critical point, is 3.06. And we can see that this graph, it's decreasing from negative infinity. So it's decreasing from negative infinity to 0.27. And it's also decreasing from 3.06 to negative infinity. To positive infinity. Sorry if I said negative infinity. Right. Okay. And it's going to be increasing, as you can see. Increasing from 0.27 to our maximum of 3.06. So increasing. And you can also figure this out if you were to plug in values to the left of 0.27, you plugged it into the derivative, you would get a negative number. So, which means the slope is negative to the left of 0.27. It's going to be positive if you plugged any x value between 0.27 and 3.06, and it's going to be negative if you picked a value greater than 3.06. Okay. 18. Find the interval of concavity of the functions f of x equals 3x cubed minus 2x squared shown in the graph below. All intervals should be accurate to 2 decimal points. Okay. So for this one, let's find the first derivative. And the second derivative. So for this one, we're going to find out where the second derivative is 0. And what that tells us is where there is an inflection point. An inflection point is going to be where it changes concavity. So if we solve for x, it's x equals 4/3. And that's the inflection point. And if you look on the graph, that's going to be just a little bit to the right of 1. So 4/3 would be about right here. Go down to your y value. This is your inflection point. So it starts to change from concave down to concave up there. So for this one, it's concave up, 4/3 to positive infinity, and concave down. Negative infinity to 4/3.